What is up, Algebra 1? We are going to move on to our next section, which is systems of equations. Okay, so there are two scenarios. Our first scenario is a system of equations. You are going to be graphing two linear lines, and our goal is to find where our two lines intersect, where they cross. The point where our blue and red line cross is the answer to our solution. We also will have systems of inequalities where there will be shaded regions, and these will all be graphed in Desmos. Our goal is to find where our two shaded regions will overlap. Wherever both the red and the blue overlap, any point inside of the double shaded region is one of our possible solutions. Okay? So that is our focus of this topic, and Desmos will be huge. Going on to question number 1. A system of inequalities is shown. Y is greater than or equal to 5. Y is less than or equal to 2/3 x plus 3. And our goal is to graph both of these. So if I pull up my Desmos, I'm going to start by graphing both of these. Pull up my keyboard. Y is greater than or equal to 5. You'll see it pop up with my shaded region. And I'm going to go ahead and I'm going to sketch that. Y is greater than or equal to 5. Okay, my line goes across through 5. And my shaded region is everything above. Okay, on to my next equation. My next equation is y is less than or equal to 2/3 x plus 3. Okay, what I want to do is select two pretty points. -4.5, not very pretty. 0, 3, and 3, 5. 0, 3, and 3, 5. So I'm going to plot 0, 3, and 3, 5. Draw my line. And shade my graph. It was shaded, just to double check, it was shaded below. So we're going to shade everywhere below. And it asks us to put a star inside of the shaded region, which is where both the red and the blue intersect. Okay, let's do another one. A theater sells tickets for a concert. Tickets for the lower level seats sell for $35 each, and tickets for the upper level seats sell for $25 each. And the theater sells 350 tickets for $10,250. So we have 4 very important numbers. Lower level seats are 35 each. Upper level seats are 25 each. And we have 10,250 is our total. We also have this 350 tickets. Now, we are looking for the one that does not belong. 350 tickets doesn't belong. The other ones all talk about money. So those are all going to go together to make our first equation. Okay? So 35x plus our upper level, 25y, equals my total amount of money, 10,250. This is my first equation for my system. Okay, so I've used my 35 each, I've used my 25 each, and I've used my 10,250, and now I just have my tickets. Okay, when you just have your little loaner left over, we're always going to have x plus y equals the one that does not quite belong. Okay, so now we're going to type these into Desmos. Let's pull open our Desmos. We'll move it over to the other side. And let's type in our two equations. 35x plus 25y equals 10,250. and x plus y equals 350. Now it looks like we can't see it, but if I zoom out, I'm looking for the point where my two lines intersect. So we have 150 and 200 are my answers. 150 and 200. Yay, next problem. Okay, similar problem. What two numbers have a sum of 217 and a difference of 85? Okay, it is important to know your math vocab. Sum means addition. Difference means subtraction. So first we have two numbers. We don't know what they are. We'll call them numbers x and y. So if I take x plus y, it will equal 217. If I take the difference, x minus y, I should get 85. Okay? Two equations is a system, so we can go to Desmos and plug them in. Delete out this old one. X plus y equals 217. And x minus y equals 85. Zoom out so you can see your system. Our answer is where our two lines intersect or cross. So our two numbers are 151 and 66. 151 and 66. And we're done. Okay, next one. System of equations is shown. What are the solutions to the system of equations? Okay? When we're given two equations, we're plugging them into Desmos. So pull up Desmos, and let's go ahead and type them in. Y equals 3x minus 2, and y equals x to the power of 2. Okay, zooming into the graph, I see that they cross 2 times, so we have two solutions to the system, 2, 4, and 1, 1. All done. Next problem. Okay, similar. A system of equations is shown. Okay, we're given two equations that we need to type in. Y plus 1. Y plus 1 equals 2x. And x squared minus 4x equals y minus 4. Okay, looking at our two graphs, I'm looking for where do my two lines cross. They cross once at 1, 1, and they cross a second time at 5, 9. 1, 1, and 5, 9. Okay, continuing on. Juan buys peaches and grapefruit at the store. He writes the equations shown to model the relationship between the number of pounds of peaches and the number of pounds of grapefruit. Okay, Desmos struggles with variables other than x and y, so what we're going to do is we're just going to rewrite these with x and y. X plus y equals 2.5, and 1.58x plus 1.09y equals 3.46, and we're asked to find the total number of pounds of peaches and grapefruit that Juan buys. So I'm going to pull up my Desmos, and I'm going to type in my two equations. My goal is finding where the two cross. Okay, so typing in my first one. X plus y equals 2.5, and 1.58 x plus 1.09y equals 3.46. I'm going to take a look at my graph. I'm looking for where they cross. They cross at the point 1.5 and 1. And the trick here, it says what is the total number of pounds of each. So if we had 1.5 peaches and 1 grapefruit, then in total we bought 2.5 pounds of fruit. Okay, continuing. Henry places X marbles into an empty bucket. Each marble has the same weight. The weight in ounces of the bucket and the marbles can be calculated using the expression below. 3x plus 8. Okay, so what does the term 8 represent in the expression? Okay, so x represents my marbles. 3 is the weight of each marble. And remember, in y equals mx plus b, this is our starting weight. So the starting weight would be the weight of the empty bucket. That is our starting weight. Farah scored 42 points during a recent basketball game. She made only 2-point shots and 3-point shots. In total, Farah made 19 shots. Create 2 unique equations that model the number of 2-point shots, x, and the number of 3-point shots, y, that she made. Okay, so we have a few numbers to look at. We have 42 points. We have 2-point shots, 3-point shots, and 19 shots total. Okay, so we have 4 numbers to use, which is perfect for making a system of equations. So, if we take all of our 2-point shots, 2 times x plus 3 times y equals, so 2 points for the 2-point shots plus 3 points for the 3-point shots would equal a total of 42 points. So if we use our 42 points, our 3 points, our 2 points, and finally we have 19, and when there's one that doesn't belong, we write x plus y equals the one that doesn't belong. To find the number that she made, we just need to graph them and find where they intersect. So I'm going to clear out these old ones, and I'm going to type them in. 2x plus 3y equals 42, and x plus y equals 19. Don't forget, you might have to move your graph around, zoom in and out, but you're finding where your 2 lines intersect. This means she made 15 2-point shots and 4 3-points. 15 2-point and 4 3-point shots. And we continue. A group of 30 students rented small canoes and large canoes at the river. The group rented twice as many small as large. There were 3 students in each small and 4 students in each large. Let x represent the number of small and y represent the number of large. And we know there were 30 students. So as you can see, we have 3 that talk about students. We have 30 students, 3 students in smalls, 4 students in large. Those 3 have to go together. Writing our equation, we have 3x, 3 people in each small canoe, plus 4 people in each large canoe, is a total of 30 people. Now we need to turn this first bullet point into an equation. Twice as many small as large. So I like to start by writing x equals y. If there were twice as many smalls as there are large, then if we multiply the large by 2, then there would be equal. Here's our 2 equations. And we're going to put them into Desmos to find where they intersect. 3x plus 4y equals 30. X equals 2y. This means there are 6 small and 3 large. 6 small and 3 large. to the next one. Okay, the graph of two functions are shown. For what value of x does f of x equals g of x? Okay, so we're seeing where are they equal, where do they cross, where do they intersect. If I go over to 5 and up to 9, they cross at the point 5, 9. Easy peasy. At 5 is where they cross. Okay, you guys know how to do this one. Here are our systems. The graph of f of x is already on our graph. We're going to add the second equation. Okay, remember to graph this, we can put it in Desmos. If we wanted to do it by hand, I would start at 5, plot a point, and then I would go down 3 over 1. Down 3 over 1. Down 3 over 1. Connect it, and I can see that these are intersecting at the point 2, negative 1. 2, negative 1. Alright. Two functions are given again. What is one value where f of x equals g of x? Pull up your calculator and let's find where they cross. Okay, so I'm going to type in f of x equals negative x squared. You really want to be sure that you're typing these in exactly. Always double check. If you mistype, your answer will be wrong. G of x equals negative x plus 1. Okay, I'm going to my graph. I'm always looking for where they cross. It says I only need one x value. There are two to choose from. I can either choose 1, which is an x value, or 3. That's an x value. Okay, next. Same type of question. The equation of two functions are given. What value of x makes it true? Okay, rinse and repeat. We are typing in our functions until we find where they cross. 3x plus 4. And we have 7x minus 2. Move your graph around and they cross at the point 1.5, 8.5. The x value, though, is 1.5, since it only asks for x. Graph the system of inequalities shown. When you have a problem where you have to graph, we have to create the system. So let us first do our line. So here is one pretty point. Here is another pretty point. This is the point 0, negative 5. And this is the point 6, negative 1. So when I'm making an equation in Desmos, I'm using my cheat code. So let's delete this out. In a table, I have 6, negative 1, and I have the point 0, negative 5. Putting in my cheat code, y1 squiggly, mx1 plus b. I can see everything I need. M is 0.6 repeating. We can turn that into a fraction. Clicking my fraction button. So m is 2/3, b is negative 5. 2/3 and negative 5. So y equals 2/3 x minus 5. That's our first equation. And now we need to do our second equation. So we're going to pick two pretty points. 0, negative 3, 1, negative 3. And we're going to go back and do the same thing. Okay, so if I go up to my table, 0, negative 3, and 1, negative 3. I can see m is 0, b is negative 3. But since we're shading below it, I need to use a less than symbol. So y is less than negative 3. And there's our second equation for our graph. Okay, multiple choice. Okay, a system of inequalities is given. For a problem like this, I don't need to run through it. You're going to type in both of your equations, and you are just looking at Desmos to see which one matches. Okay? Putting it into Desmos to see which one matches. Okay, Luke compares the solutions to two systems of linear equations. Complete the statement to show Luke's comparison of the two systems of linear equations. The solution to system 1 will be, and the solution to system 2 will be. So it is time to plug and chug. Plug and chug. System 1. Y plus 2x equals 3. And 3y plus 3x. Oop, I got an extra 4 in there. 3x equals negative 4.5. Okay, seeing where they cross at 4.5, negative 6. 4.5, negative 6. For our second system, we're doing the exact same thing, plugging it in. Negative 3x minus 6y equals negative 9. And 3y plus 3x equals negative 4.5. And there we go. Negative 6, 4.5. Okay, next one. A system of equations is given. Which system of equation has the same solution? Okay, so you're plugging this into Desmos and finding your solution, and then you're going to check each one of these and find their solutions and figure out which one had the same solution as your original problem, all on Desmos. Last but not least, a system is shown. What is a solution? Our solution is where our graphs intersect. You have two to choose from, either 2, 5 or 5, negative 1. Either one is allowed. Alright, that is your systems of equations. Your homework is to now go and move on to exponential functions.